National Electrical Code Section 230.54b addresses service entrance conductor requirements. This section states that the service entrance conductor shall not be spliced or tapped within 24 inches of the point of attachment to the service equipment or meter. The reference to service entrance conductor in this section refers to the conductors that connect the electrical meter to the electrical panel inside the building. The 24-inch distance requirement applies to the length of the conductor between the point where it attaches to the meter or service equipment and the point where it is spliced or tapped. Splicing or tapping within this 24-inch zone is prohibited. This requirement ensures that the conductors are properly secured and supported near the service equipment or meter, where they are most likely to experience bending or movement. Splicing or tapping in the zone could weaken the conductors and increase the risk of electrical hazards, such as overheating or short circuits. The NEC does not specify a maximum distance between the weatherhead and the point where the service entrance conductors attach to the service equipment. However, it is recommended to keep this distance as short as possible to minimize voltage drop and reduce the risk of damage to the conductors. Your interpretation of Section 230.54b is correct. The 24-inch distance requirement applies to the length of the service entrance conductor between the point of attachment to the service equipment or meter and the point where it is spliced or tapped. It does not limit the distance between the weatherhead and the service equipment. Let's delve a little deeper into service entrance conductors. These conductors are the lifeline of your electrical system, bringing power from the utility company's service drop to your building's electrical panel. Understanding the NEC requirements for these conductors is crucial for ensuring a safe and reliable electrical installation. The 24-inch rule in Section 230.54b is a critical safety measure. Think of it as a buffer zone around the service equipment or meter. This area is particularly vulnerable because the conductors are subject to stress from physical movement, temperature changes, and potential vibrations. Any splice or tap in this zone could compromise the integrity of the connection, leading to loose connections, arcing, and potentially a fire hazard. The key here is to ensure that the conductors are continuous and properly supported as they transition from the outside to the inside of the building. This means using appropriate fittings, connectors, and securing methods that are listed for the purpose. The goal is to minimize any stress or strain on the conductors and to prevent them from becoming dislodged or damaged. Now, let's talk about the weatherhead. The weatherhead is the fitting at the top of the service mast that protects the conductors from the elements as they enter the building. It's essential to use a weatherhead that is specifically designed for service entrance conductors and that is properly sealed to prevent water from entering the conduit. While the NEC doesn't dictate the exact distance between the weatherhead and the service equipment, it's generally best practice to keep this distance as short as possible. Firstly, a shorter distance minimizes voltage drop. Voltage drop occurs when the voltage at the service equipment is lower than the voltage at the utility transformer due to the resistance of the conductors. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. Secondly, a shorter distance reduces the risk of physical damage to the conductors. The longer the conductors, the more susceptible they are to wind, ice, and other environmental factors. By keeping the distance short, you can minimize the exposure of the conductors to these hazards. Thirdly, consider the practical aspects of installation. A shorter distance makes it easier to support the conductors and to ensure that they are properly protected. It also simplifies the process of making connections to the service equipment. To ensure compliance with the NEC and to create a safe and reliable electrical installation, firstly, always consult the latest edition of the NEC and any applicable local amendments. Secondly, use qualified and licensed electricians who are familiar with the NEC requirements for service entrance conductors. Thirdly, inspect the installation carefully to ensure that all conductors are properly supported, protected, and connected. Fourthly, pay close attention to the 24-inch rule in Section 230.54b and avoid any splicing or tapping within this zone. Fifthly, use appropriate fittings, connectors, and securing methods that are listed for the purpose. Sixthly, ensure that the weatherhead is properly installed and sealed to prevent water from entering the conduit. Seventhly, keep the distance between the weatherhead and the service equipment as short as possible to minimize voltage drop and reduce the risk of physical damage. Eighthly, consider the environmental conditions and choose conductors and equipment that are suitable for the specific location. Ninthly, document the installation carefully, including conductor sizes, conduit types, and grounding methods. Tenthly, perform regular maintenance and inspections to identify and address any potential problems before they become serious. Remember that the NEC is a living document that is constantly updated to reflect changes in technology and best practices. It's essential to stay informed about the latest requirements and to apply them diligently in your electrical work. A well-designed and properly installed service entrance system is the foundation of a safe and reliable electrical system. By following the NEC requirements and using sound engineering judgment, you can ensure that your electrical system will provide years of trouble-free service. Let's consider some practical examples of how the 24-inch rule applies in different scenarios. Imagine a situation where you need to extend the service entrance conductors due to a change in the location of the service equipment. In this case, you cannot simply splice the conductors within 24 inches of the meter. Instead, you would need to run new conductors from the meter to the new location of the service equipment, ensuring that there are no splices or taps within the 24-inch zone. Another common scenario involves adding a subpanel to an existing electrical system. If you need to tap into the service entrance conductors to feed the subpanel, you must do so outside of the 24-inch zone. This may require installing a junction box or other approved enclosure to make the tap connection. It's also important to consider the grounding and bonding requirements for service entrance conductors. The NEC specifies how these conductors must be grounded to ensure that the electrical system is properly protected against faults. Proper grounding and bonding are essential for preventing electrical shock and fire hazards. The service entrance conductors must be grounded to a grounding electrode system, which typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode conductor must be sized according to the NEC and must be securely connected to the grounding electrode system. In addition to grounding, the service entrance conductors must also be bonded to the service equipment enclosure and to any other metal parts that are likely to become energized. Bonding ensures that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. The bonding jumpers must be sized according to the NEC and must be securely connected to the metal parts. When working with service entrance conductors, it's essential to use appropriate personal protective equipment, including rubber gloves, safety glasses, and insulated tools. Never work on live electrical equipment unless you are qualified and authorized to do so. Always to energize the circuit and verify that it is dead before working on it. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. If you are not comfortable working with service entrance conductors, it's best to hire a qualified electrician to do the work. A qualified electrician has the knowledge, skills, and experience to perform the work safely and correctly. In summary, understanding the NEC requirements for service entrance conductors is essential for ensuring a safe and reliable electrical installation. The 24-inch rule in section 230.54b is a critical safety measure that must be followed. By following the NEC requirements and using sound engineering judgment, you can create an electrical system that will provide years of trouble-free service. The correct interpretation of section 230.54b is vital for electrical safety and code compliance. This section of the NEC specifically addresses the limitations on splicing or tapping service entrance conductors within a defined proximity to the service equipment or meter. The key takeaway is that the 24-inch restriction applies to the distance along the conductor from the point of attachment to the service equipment or meter, not the overall length of the service entrance conductors or the distance from the weatherhead. Firstly, let's clarify the term service entrance conductor. These are the conductors that carry electrical power from the service point, typically the utilities connection, to the service equipment, which includes the main disconnect and overcurrent protection devices in a building. These conductors are critical for delivering power safely and reliably. Secondly, the purpose of the 24-inch rule is to ensure the integrity and safety of the conductors near the connection points. Splicing or tapping in the zone can create weak points that are susceptible to stress, overheating, and potential failure. The curve mandates a continuous unspliced conductor length within the zone to minimize risks. Thirdly, the NEC does not specify a maximum length for service entrance conductors from the weatherhead to the service equipment. The primary concern is to minimize voltage drop and ensure the conductors are adequately supported and protected. Longer runs of service entrance conductors require careful consideration of conductor size to prevent excessive voltage drop, which can impair the performance of electrical equipment. Fourthly, when installing service entrance conductors, it's essential to use appropriate fittings and connectors that are listed for the purpose. These fittings must provide a secure and reliable connection that can withstand the stresses of the environment, including temperature changes, vibration, and physical strain. Fifthly, conductor support is another critical aspect of service entrance installations. The NEC specifies requirements for supporting conductors to prevent sagging, strain, and potential damage. Support methods may include insulators, clamps, and conduit systems, depending on the specific installation. Sixthly, grounding and bonding of service entrance conductors are crucial for electrical safety. The grounding system provides a path for fault current to return to the source, tripping over current protection devices and preventing electrical shock hazards. Bonding ensures that all metallic parts of the electrical system are at the same potential, minimizing the risk of shock. Seventhly, the weatherhead is the fitting at the top of the service mast that protects the conductors from the elements. It's essential to install the weatherhead properly to prevent water from entering the conduit system and causing damage to the conductors. Eighthly, voltage drop is a significant concern in service entrance installations, especially for longer runs of conductors. Voltage drop can cause lights to dim, motors to run inefficiently, and other electrical equipment to malfunction. The NEC provides guidelines for calculating voltage drop and selecting appropriate conductor sizes. Ninthly, regular inspection and maintenance of service entrance conductors are essential for ensuring their continued safety and reliability. Inspections should include checking for signs of damage, corrosion, or loose connections. Any issues should be addressed promptly to prevent potential problems. Tenthly, always consult with a qualified electrician or electrical engineer when designing or installing service entrance conductors. These professionals have the knowledge and experience to ensure that the installation meets all applicable codes and standards. Understanding the nuances of Section 230.54b is crucial for electrical professionals and anyone involved in electrical installations. By adhering to the code requirements and following best practices, you can ensure a safe and reliable electrical system.